going. So there's two major additional features that require explication for this open population model. One of them is births, and one of them is deaths. Okay. Now, the birth one has a lot of similarities to what we've just been talking about, but a few small differences. I'm going to go and I think what I'll do first is put in place the births because of that, and then I will go and explicate the deaths within the model. Okay, so what I'd first like to do then is to think a little bit with you about how we are to capture births within this model. Okay, so right now we have immigration being captured through this event at this level of the model as a whole. I'd like to think, okay, how are we going to capture births? Kurt, this thing got kicked off the network. Could you reconfigure it? Thanks. So I'd like to figure out how to represent births. So give me one way that we might represent births within this model.
You could just do events.
Yeah, we could have an event, and that event could be at two different levels. What's one place that event could live? Could live in person. So we could have an event going off within a person that represent the occurrence of a birth, right, for that individual. Given that we have sex in this model, it would need to be configured so that it would only go off in women, but it would go off at a certain fertility rate, right? So that'd be one way to capture it. Another way to capture it would be have a birth event in Maine, which would go off at a rate proportional to the number of people in the population. So the idea is that if there were 100 people in the population, thanks a bunch, and there was a certain chance per year that each of those persons gave birth. Kurt, would you mind throbbing this? It looks like Google Docs has crashed. Thanks. We could then have that rate go off. So suppose there were 1,000 people in the population, and the birth rate were 1%. Then on average there'd be 10 births per year occurring. That would be another way to capture it. And we'd somehow have to keep that one in sync with the number of people in the population. So in many ways, because of that, we'd have to do some extra work to make sure it's going off at the right rate given the number of people in the population. In many ways, as Roberto suggested, it would be more convenient to do so at the level of a given person. Okay, so maybe there's something else going on. Okay, so ladies and gentlemen, I would like to therefore focus on doing this within each person. Okay, and we're going to go down to person within the model, and we will then go and put in place fertility, and we will put in place some mechanisms for capturing mortality there as well. Okay, so we're going to go to the level of a particular person. Okay, and within this person, we're going to have a process that characterizes births. Okay, now as noted by Roberto, we could just do it with an event here. We're going to in fact put in place a state chart. Okay, and the state chart will reflect the fact that there's a pregnancy, and the pregnancy occurs with a certain length, and it will capture the fact, therefore, that if there's one pregnancy, there's some minimum time before another pregnancy can occur. Okay, so I'd like to start here a state chart that's going to be a pregnancy state chart, okay? So in order to do that, we're going to go to the palette, and we're going to put in place a state chart entry point, and it's going to be called pregnancy state chart, okay? Great. And for this pregnancy state chart, there's going to be two states. One that's going to be not pregnant, and one that's going to be pregnant, okay? Great. And there's going to be transitions between them, okay? Great. So the transition here is going to be from non-pregnant to pregnant is going to be one associated with a new pregnancy, and it's going to be dictated by fertility rates, okay? So we're going to drag in here a new transition, and this is going to be we'll call it conception, perhaps, and it will be triggered by a certain rate, okay? And the rate here will be given by a fertility rate, and that fertility rate is going to be changing for different points in the life course, okay? But importantly, we're going to put in place what's called a guard, and this guard will basically make sure that this is limited to women, okay? So a guard basically means that this transition will only be able to occur if a certain condition is true, and the guard will encode that condition. So the guard here will be this dot sex double equals female, okay? So it's only if the sex is female that that the person will be able to transition here. The woman will be able to transition. The reverse transition, by contrast, will be dictated by a fixed timeout, and we could make that timeout, we could draw it from a distribution if we wanted to. For now, we're just going to say a timeout of 9 months, okay? 9 months. Okay, and that's going to be called birth, okay? So a woman will start initially non-pregnant, someone will become pregnant. While in a pregnant state, they'll be there for 9 months, and then they'll give birth. Okay?
Can I have a question?
Yes.
Should you have a gap on how young old the person is? 'Cause, you know,
We could do that, or we could have the fertility rate be 0 for large portions of it, and then it's only when they're in a certain phase of life that they will have a non-zero fertility rate. This transition here will be guided by a rate that's going to be given by a fertility rate. Now, why would you be cautious about using a guard for that? Well, guards are only reevaluated when you come into the state out of which they leave. So guards are associated with transitions, and the only time at which that guard is reevaluated is if you leave and come back into the state, or if you come into the state. It's actually not re-examined. So if that person is aging and there was a guard here about their age, we'd need to somehow find a mechanism to force it to reevaluate that guard, okay? So it's actually better to not have the guard depend on things that are changing over time. If it does, we need a transition that will actually leave this state and come back in the state from which it comes, okay? We'll actually see that later, and likely in one of the models. Okay, ladies and gentlemen, so we're gonna have a fertility rate here that's gonna vary with age, okay? This fertility rate is going to be encoded in what's called a table function, okay? So this is going to be called fertility rate for age. Now, I actually have a very nice table of values to use for this that I'm currently unable to find on this tablet. So you're going to have to excuse me for just a minute while I go find this in the model. Okay, there we are.
In the meantime, does anybody need a hand getting caught up?
Okay, so ladies and gentlemen, so for this, this table function is going to describe for a particular age what's the fertility rate, okay? So in order to do this, we're going to go open up that fertility rate, okay? That fertility rate for age table, and we will see in it a table of values. It's a little bit like what we saw with the distribution, okay? So we're going to put in place some values for this, okay? So this is going to be the age-specific fertility rate. So for 0, it's going to be 0. For 12, it will be 0.001. For 25, it will be 0.05. For 40, it will be 0.02. For 45, it will be 0.005. And for 90, it will be 0. Okay? Now, there's a couple of things we still need to do. First of all, we'll go on and preview this. This is what the curve looks like, okay? It interpolates. Now, the reason it interpolates, thank you for the question. The reason that it interpolates is that you'll notice up here at the top of the table function, it says, should I use linear interpolation? Should I use just steps? In other words, it will jump up here at those places. Or should it do something more sophisticated, like a spline, where it will actually twist around? Now, one of the problems with splines is they can go negative. They end up twisting into a negative region. So you got to be cautious. They look kind of nice, but you have to be cautious with them. Okay? So I'm going to use linear. And the other thing we have to be careful about is this out of range thing. So if someone's greater than 90, should it just give an error? Or should it take the nearest one? What should we do? And we're going to say nearest here. Okay? So if someone's more than 90 years old, it will just use 0. Are we okay with that? Okay. Ladies and gentlemen. Okay. So what I would like to do now then is that's the fertility rate for age. Could have called it age-specific fertility rate. Now for this transition here, what we need to put into place here is a rate transition which will look up the fertility rate for age for their current age. Can anyone tell me a formula that might do that? How do I refer to the fertility rate for age? This fertility rate for age. And you'll notice that when I auto-complete that, it can look up a value for me. So again, we could either give, there's a way to refer to it that just refers to the whole table function, but that's not what we want. What we want to use for the rate is not the table function. We want to look up a value in the table function. So it's fertility rate for age, and what do we have to give it for it to do its job? Yes, we have to give it this dot current age. We have to give it our current age. So we're going to look up our current age, and we're going to ask the fertility rate for age what the fertility rate is at that age. Does that make sense? Okay, now, I want to tell you something that is an unpleasant fact. And I wish I didn't have to tell you this. Let's run this thing and see, okay? Okay, we're going to run it. And here we go. We're going to undergo a run, and And here are people coming in. You know, I'm sorry. We haven't yet had the baby born, have we? We haven't yet put anything in for the birth of the baby. Let's do that. Can we do that?
Transition. You're going to show today with the transition.
Thank you. Thank you. Thank you. Show name. And for this, show name. Okay? Okay. So for the birth transition, ladies and gentlemen, this is going to be the happy event. Are you ready? Okay. Okay, we're first just going to do this. We're going to say this dot, actually, yes. Okay, I'm torn about how to do this. Yes, we could say main dot, yes, you could say this. Main dot add underbar population, and we're going to add a baby in. What will its birth time be? Will it be 0? The current time. Current time. The baby will be born at the current time. And its sex will be randomly chosen. So we're going to say random from sex.values. Okay? Now, I know that's a bit of an eyeful. Let me put it up on the big screen. Now, maybe that's still an eyeful. We could put it this way if you want to clear it up. This is going to draw random sex, and this is going to be when the baby is born, the current time. Now, if you don't like that, we could again use variables to simplify it. Should we do that? Do you want to see variables used?
I like it.
You like it? Okay. Let's use some variables to simplify things, okay? Here we go. Okay, so we're going to create a variable called baby's sex, okay? Sex, baby's sex. We can't put an apostrophe, unfortunately. Okay? There's the sex of the baby.
Simplify, but you've got to do more work.
Well, sometimes looking at this can be confusing. People like, what does this mean? And by giving it a name, it can actually communicate what that thing is that's being used. But
Defining variables,
to give a nice name to it that makes it clear what is that thing. Now, as I said earlier, as I emphasized earlier, as opinions differ about how desirable this is. Some people will say it is desirable, some people will say it's more cruft, it's more things to look at, it actually confuses things. And a lot of it depends on how comfortable you are reading this sort of thing. After a while you can come to read it fairly readily, but some people find it easier to just say baby's, birth time, baby's birth time, to do this, and then to pass that, and it just makes it clear when I'm adding this population member, it's for the baby. It's for the sex of the baby and the birth time of the baby. There we are. Now the baby is added to the population.
Is baby's birth time double, not time?
It's a double. I wish it were a time. Wish it were a time. If it had that extra semantics, it would be a thing of beauty. But the world is imperfect, so we must settle for success, as Jeff said. Sorry?
It's not a date.
It's not a date. It's the current time. You can ask for the current date too. You can ask.
And is that double or date?
Well, current date would be a date. I can't remember what it is, but you can ask for the. It will give you actually a date back for the current. It's a full date and time for the current time. 9 a.m. on, July 31st, 2017.
And you can convert that back to the model time as well. So whatever makes the most sense in your situation. So for instance,
So time is model time.
Time is model time.
So I'm currently playing a bit with a farm-related model, and obviously that has seasonal effects to it. So during certain months there's weather tied to those months or precipitation patterns tied to particular weeks. And so for me, even though I would almost always use time like that, in that particular model, using dates might be a really useful thing to do. But in most models that you build, particularly in health, and I think this is a safe thing to say, Nate, that you would just normally use time, and the dates would be less important.
Well, not necessarily. I mean, for health service delivery,
Yeah.
dates are really important. Even, at detailed level, the opening time of a clinic.
Right.
Even at other levels like winter means more people saying to the clinic for flu.
Yeah, exactly.
And then there's of course there's the present doctors go to conference season. So like there's no surgery done on day X because it's the coronary conference. Yeah.
So that's a good question. Are you going to cover, can you cover schedules in this, or maybe just demonstrate what a schedule might look like?
Yeah, this afternoon, Kurt may cover a bit of that in his discrete event model, or I may after I come in and relieve him. We'll probably cover schedules a little bit there, opening time and closing time of clinics, or whether they're open on weekends, etc. Yeah, holidays. Yeah. Okay, ladies and gentlemen. So here we've added this baby into the population. So now we should be able to run the model, and you will see something going on. The problem is that we have immigration going on. How could we turn immigration off so we could see if the model's working? This is an important thing. Often we want to develop confidence. Is our model even working here? How could we disable immigration? We could set the rate to 0. And one way to do that would be doable but very undesirable would be to go into the model and change immigration rate to 0. What's a better way we can do it? Sorry? So we could, visibility? Well, we could change it to disabling it wouldn't be that effective. But one thing we could do, well, let me just draw attention. Immigration rate is a parameter. So what could we do? Yes, in another experiment. So let's create an experiment, a new experiment that's, no immigration. All right? And for that experiment, the immigration rate is going to be 0. What do you think? Is that okay? Immigration rate will be 0. We didn't have to modify the model. We just created a new experiment, a new scenario, where we changed the model. And so here we go, and there are people coming in. Who are those people? They are indeed. They're neonates, and they are coming in. Okay. Yeah.
Neonates.
Oh. I didn't think many people would notice that.
Middle or after?
Sorry?
Am I a neonate because I'm after Nate?
So, moving right along. Okay, so ladies and gentlemen, so no immigration. We actually see that there's some people coming in. They could be born. Now we could color them differently if they are new births very readily. We could have different colors for people who are immigrants, people who are born in the model, people who started in the model. But I want to show you something that's broken in this model. Okay? Ladies and gentlemen, there is a big problem in this model. Could I show you what it is? Okay. In order to demonstrate this problem, I'm going to do something to show you, and I don't want you to follow this, okay? Because I don't want to get people confused. I'm just going to do something to show you. I'm going to go in to main, and I'm going to set the initial age of the population to, instead of being drawn from the age distribution, I'm just going to make everyone born at time 0, or everyone starting at age 0, okay? So everyone will be at that age. Now, the way I'm going to do this may be a bit instructive, but I don't want you to do it, okay? I'm going to multiply birth time by 0, okay? It's going to be 0. If I really want to be pedantic, I can make it 0 plus. This is a way of temporarily disabling this and just making it 0 from now on for the birth time. This is just one way to do it. Now I'm going to run this simulation with no immigration, and we're going to watch this. Let's go see the fertility of this population. Okay, time is moving on. Centuries pass. Empires rise and fall. And there's nobody coming into this population. Why? It's not retesting the age. Beautiful. Yes, that's exactly it. It's not retesting the age. That's exactly what's going on. So when they come into this state, it's determining their fertility rate when they come in, but it's not re-examining it. So the ugly fact here that I'm sorry to tell you is that AnyLogic does not automatically recompute rates that depend on ongoing changes. Now it will if it's based on the change of another state chart, but by default it won't. In this case, their age is going up on a continuous basis. So first of all, I'm going to undo that change I put into the flat. Well, should I? Maybe I'll leave it for now until we can have confidence this is working. So let's go back to person, and this is the ugly nod we're going to have to put in. And I'm sorry to tell this to you. This is one of the places where I almost feel a mark of shame. Okay? We're going to go to the state chart area, and we're going to drag in a transition. Now this transition is going to be unlike every other sort of transition we've yet examined. It's going to be a transition from not pregnant to not pregnant. And the way I'm going to drag it, I'm going to drag its originating end at not pregnant, and then I'm going to double click on it in 2 places so I can bend it to my will, like that. And then I'm going to drag this final one like that. So it actually comes out and goes in. This is key. AnyLogic actually understands it differently. If it doesn't actually come out of the state, it considers you as never having left the state, just like something going on whilst you're in the state. Here it's actually leaving and coming back in, and every 1 year it'll go out and come back in. And this will be called recalculate fertility rate. Every 1 year. Now we could make it every month if we wanted to. It'll recalculate it on a finer grained basis, but I reckon that would be false precision. This would be an adequate recalculation frequency. Okay, ladies and gentlemen.
So Nate, are you saying that if you did one of those internal transitions, it would treat it differently?
Yes. Yes. An internal transition does not leave the state, and therefore it doesn't come back in, therefore it doesn't recalculate this.
Oh, okay. But I just thought it was a cosmetic thing that you took it.
No,
That might explain some of the air circuits.
yeah, no, yeah, it was an eye-opening moment to see that. Okay, ladies and gentlemen, sorry, now I should go, this is no immigration, and now we should start to see some births. Why? Because before, everyone was starting at age 0, and it was calculated fertility for them, fertility 0, and they retained that fertility forever. They just remained in this non-pregnant state because it had no chance of going. Now that we've put this in, it's going to be re-examining it. As they age, every year it's going to be re-examining this, and eventually their fertility rate will creep up, and they'll be able to get pregnant. Okay? So let's go take a look at this. Boom. Run no immigration, and we're going to do this, and oh, look at that. Okay. Now the model is exhibiting a sizable population. Okay, great. Okay, ladies and gentlemen, we still don't have mortality in, but at least we have these components. Okay, so ladies and gentlemen, now we have this. I've basically verified it, that it's now having people come into the model. So I'm going to remove this constraint. So now some people begin older, some people younger. Okay? And we should be able to run it. And here people come into the model. Now, curiously enough, they stop coming in after a while. And I'm not I'm disconcerted by that. Okay. Besides the fact that their age is very, very much older, they're actually stopping coming in after a while. Why is that?
Is that because everyone's older than
Oh, too
90?
old.
Yeah, but you would think that they would have given birth to younger people yet.
I think the fertility rate's so low that it actually dies out. Because it's actually quite long fertility.
You're right.
So I think that eventually.
You're right about that. It is low fertility. It may be that they don't even replace themselves, and so basically the population ages. It becomes the fertile population becomes smaller and smaller and smaller, and then it basically peters out. Okay, so a good point here. I think that's probably what's going on.
Were you running at no immigration?
Sorry?
Were you running the no immigration?
No immigration, yeah. Okay, ladies and gentlemen. Okay, now we want to put into place mortality, okay? Mortality. For the mortality profile, we will also put in place a table function. And we're going to put that into place here in person. So we're going to add in a table function here, okay? So this is going to be a table function. We're going to look up from their age, and this will be called mortality rate from age. And I'm going to locate it over to near fertility rate, okay? And for this, we're going to put in place a different set of values, okay? So the mortality rate for age, for 0, it's going to be 0.002. For 5, it's going to be 0.001. For 18 years old, it's going to be 0.005, reflecting the riskier teenage years. 25, it's going to be 0.002. At 40, it's going to be 0.005. The risk has gone up again. At 50, it's going to be 0.01. At 60, it's going to be 0.02. And at 70, it's going to be 0.05. Oops, 70, 0.05. And at 80, it's going to be at 90, it's going to be 0.1. Excuse me. 90 at 0.1. Okay. 90, 0.1. Okay. So that's our mortality rate, and it should look something like this. Okay. This is the teenage bump, and it's going to go down, and then it's going to rise.
Can you show the table again?
Oh, I'm sorry. Yeah. Here we go.
Out of range 2 years.
Sorry.
Out of range 2 years.
Yeah. Sorry, I hadn't gotten to that yet. But yes, interpolation will be linear. Out of range will be nearest. Oh. Thank you. I hope that's not tribute. Thank you very much. Okay. Nearest will be for out of range. Okay? Are we okay with that? Okay. Now, ladies and gentlemen, we're going to put in place mortality transitions. Okay? Now, we could do this in several different ways.
Oh, Nate, sorry, can you show the table one more time?
Sure.
There's a few people catching up with all that.
Sure. Again, the numbers aren't that important, but yeah. Okay, I'll read it out. 0, 0.002. 5, 0.001. 18, 0.005. 25, 0.002. 40, 0.005. 50, 0.01. 60, 0.02.
Can you put it in a table somewhere?
look off here. Just 20 seconds.
70, 0.05, 90, 0.01. Oh, sorry, 0.1.
Really, as long as it increases as a person gets older, I think that's the effect that's trying to be achieved.
I
Yeah.
think the under 5 had to be higher though.
Okay, sure.
Because it's like a U shape actually.
Sure. Do you want to be 0.01? Well, that's pretty high. 1% of births
Yeah.
is
And neonate is really, well, not really.
5 per thousand. Okay, 0.005.
Yeah, I'll tell you.
It's kind of comparable to the yearly risk associated with the teenage years.
Apparently.
Yeah. Okay.
Motorcycles and births.
Yeah, I think the under 5 mortality in Australia is about 3
Okay.
over 1,000,
Okay.
so 0.05 is not bad.
Okay. Okay. This is an annual hazard rate, annualized hazard. Okay. Great. Okay. Now we can capture mortality in a number of different ways as well. I'm pondering how to best capture it here. So one way would be to have transitions from these two states. That's a fairly straightforward way. Another way is we could have a living state chart and then a death transition from that. And then we'd only need to have one transition. We could also do it with an event, but we need to get the event to be recalculated because over time its rate would be changing. So any of these would actually be doable.
Actually, the pregnant thing, aren't you only going to kill women?
Sorry?
If you put mortality into the pregnancy thing, you're only going to kill women.
This is true. This is true. And so I'm not doing that. Yeah. Part of me was wondering, do I really want to? There's another thing too, because if you leave this state and come back in, after every 1 year, in fact, you're never going to re-enter the state because you'll always give birth before that. So I prefer not to deal with this. So this would be sort of mortality state chart, I'll say. There'll be a single state, and this will be called living, and then there'll be a final state, which will be called dead, expired. Sure. Well, dead. Okay. And then there'll be a transition between them called death. Okay. Now, make sure they connect. Okay. So this final state, which is a little bit of a Death Star appearance, this state is going to mark sort of an absorbing state. You can actually have multiple state charts going to a death state, so others can link to it. Okay, so here the transition is going to be called dying, and it's going to be associated with a rate transition as given by what? What do you think? So what am I going to type? Good, that's a good start. And then what? Mortality rate from age. And what's the age? This dot current age, my current age. Yeah. Good. Does this need a semicolon? No, we're just computing a value. We're not telling it to do something. We're just computing a value. We're not telling it, make this change. Great. Okay. Great. So mortality rate from age. Let me put it up on the big screen. That's what we have. Okay. Great. Okay. So, at this point of when someone enters this dead state, they need to be removed from the population. Okay? Now, there's two ways to do this. One way is elegant, but it doesn't work well if you have a hybrid model with discrete event modeling, but enjoys the virtue of brevity. The other way is only slightly more involved and it works consistently. I'm going to choose the slightly more involved one that works consistently. So the action here will be, we're going to be asking main. You notice we're asking main, not this. We're asking main to remove underbar population. Remove me from the thing called population, and I'm removing myself. And there is the crowning glory. We refer to this here. Who is this? It's myself. I have died, and therefore I'm removing myself from this population in Maine. That's why I tell it, remove me. That's me, this. Okay? I told you we're coming up with an example where it's always this dot. That's telling Maine, hey, remove me from this population. Remove me from the population. That's where an example where I have to refer to this. Are we okay with that? Okay. Ladies and gentlemen. Ladies and gentlemen. Okay, that's going to capture most of it, but there's one more thing we have to do. External transition. Let's just copy this one and bring it over there. Paste, and I'm going to move it over. There we go. There we go. How did I do that? Okay, how did I accomplish that? Well, it's actually pretty straightforward. You just go here, you do copy, you can do Control C, or you can do edit copy, and now I'm going to do paste. Boom. And now I'm going to, oh my gosh, that got twisted in a straight, oh man. Okay, that's not good. Okay, this is getting twisted in a weird way if you route it certain ways. I'm moving it with my arrow keys. There we go. It docked in there. All this is going to do is recompute this. Okay? Are we ready for that? Okay, who needs a bit more time?
Gonna need a moment here.
Okay.
You were saying the slightly more involved rate. Can you throw that up? The final statement.
Yep. So I'll put it up in the big screen. Are we okay?
Does anybody else need help before we move on?
Could you show us the one that's
Could I show you?
this one again? Just
Oh, sure.
just check.
So if you want to see this, this is what that transition looks like.
Okay, now
Okay, that makes sense. Yeah, I just didn't know if you see how.
Okay?
Yeah, fluctuating, but it's not.
Okay, for those who are comfortable with it, you can run your model now. And the model will run, and unfortunately it exhibits a non-sustainable population without immigration. The birth rate is too low. What's that? An Italian population? Okay, or we could run with immigration going on, and you will see a population that is maintained, but by virtue of population. You'll notice the average age is going right around 52 or so on, or so.
So mortality rate for age.
Okay.
Go to the function mortality rate.
Okay.
And see what kind of number.
Now we're going to do one or two more things here, ladies and gentlemen. We're gonna up the ante slightly. Okay. Okay.
Give it a number.
Okay. So, ladies and gentlemen, are we ready to go forward? Okay, we're just about done with this little example. So, what I want to do is to take us where no person in this room, other than the TAs and instructor and Jeff, have gone before, and Ante. Okay. Okay. So we're going to up the ante. Okay. So. Okay. So ready? We're going to go to the palette and we're going to drag in. Well, I want to have each person keep track of who their mother is. After all, Mother's Day was just passed.
Sorry, did you run yours yet?
Did I run it?
Yeah.
Yeah.
Oh, what now? We were looking here. We're getting something interesting here. I'm curious if you're the same. So you're running the non-immigrant one?
If you run the immigrant, it basically dies out. If you run the immigrant one, it goes up and it stabilizes at a population. Well, so mine stabilizes around 3,800, 3,900 agents. Is the immigrant on?
Yeah. It's still dying. I mean, there's still people born.
Okay, Dylan, could you check that out? Okay. Thank you, Joe. Okay, thanks, Simone. Okay, so ladies and gentlemen, just thinking how to best use our time here. We're going to have each person keep track of their mother. Is that okay? Okay. Ladies and gentlemen, so how would we have each person keep track of their mother? Oh, thank you. Sorry. Okay, with a parameter. We could actually have a parameter because the mother won't be changing. Once a mother, always a mother. All right? So we're going to have a parameter called mother. And what type will it be? It'll be a person indeed. Now, what I want to draw your attention to is the implications of having introduced that. Okay? If we try to build the model now, it'll be an unhappy camper. Because we're only giving it 2 parameters. It's expecting 3 now. Why 3 parameters? What else is it expecting? Mother, indeed. So let's go systematically and change that. So you'll notice that it gives us 2 problems. So the first of them occurs, not surprisingly, in immigration event, where it's demanding from us a value for mother for the immigrants. And I don't want to get into that because the mother is probably outside of our population. So we're going to give it a value for mother that's just a placeholder value. It says no, there's no mother recorded. And we're going to give it something called, this may turn some of your stomachs, null. N-U-L-L. This means a reference to no particular mother. Okay? No specific mother. Okay? No specific person is the mother. No. Okay? Null has been turned $1 billion mistake by its creator. I think actually more than a billion. And I happen to agree. But There's much more elegant ways to handle that in modern programming. Okay, so this is null. We're giving a value, it's a placeholder value for the mother, saying we have no mother. Okay, so that's for the immigration event. For the event for birth, we also have an error here occurring for birth. And here we need to give a mother. So who's going to be the mother of the baby? Here's birth taking place. Who's the mother of the baby? It's going to be this. The current person, this. Remember, it's the current person who's going across on birth. So that's the mother of the newborn baby. Are we okay with that? Are we okay with that? No.
That's basically the mother of the child. The mother of the person died.
So this is the baby is being born here with these characteristics. The baby's sex, the baby's birth time, and this is, and I am the mother.
Yeah.
So it is this. Okay? This. Okay. Ladies and gentlemen, we added a parameter of mother to person. Mother. And it's of type person. Okay, who else needs help?
A bunch of populations are dying out for whatever reason, and it doesn't seem to have anything to do with random number C. It's just
it's at the time. I found it online, and it's because you select rate in the dying rate.
Oh, it was set to a timeout rather than to a rate. Yeah. Okay.
There's been some other issues about having the birth time set to years as the time units. That was, seems like lots of different changes.
Okay.
Lots of deviations. Of course.
Okay.
Sorry.
Yeah.
About those loop ones.
Yeah.
So why do they time out for 1 year?
They're timed out to 1 year. That's fairly arbitrary that it's 1 year, but the grand point of them, their whole job in life of these loop transitions is to get them all to recalculate periodically the hazard rate for in this case, fertility rate for going from here to here. So this fertility rate depends on their age. And unless we tell it to recalculate it periodically, it'll just keep it fixed. The first time they come in here, it'll say, what's my age? And we'll figure out the fertility rate for that, and it will just use that on an ongoing basis. So we need to tell it, hey, go recalculate it. And the way to do that is to get them to come into this state. It's actually not the only strict way. There's a more advanced way, but this is the way that's a little bit clearer. And basically you're telling it, hey, go recalculate your rates. So when you come into a state, it actually goes and tries to figure out the timing for all exiting transitions. Now, when I said tries, it actually can't, there are certain transitions we'll learn about, like a condition transition and a message transition, agent arrival transition, won't be able to figure out when those will occur. But for transitions like rates and timeouts, it actually determines what the values of those are when you come into the state. And it uses them from then on. So when you come into the state, it figures out what this rate will be, and it sticks by that rate from then on. And so the only way to get it to redo that is to get, or the most convenient way is to get it to kick out of the state and come back in, and then it will recalculate that rate. Because it's when you come into this state that it figures out the timing. That's why, Joe, when you saw that model running and it was counting down, that blue count, it figures it out. When they come into the state, it figures out when they'll be leaving via that transition, if nothing else gets in the way. And so it actually is figuring out what the rate is and when they'll be leaving. And in order to get it to recalculate it, you have to have it come out of the state and back into it. Because every time it comes into the state is when it figures those things out. I don't know if that's helpful. But
Yeah, I was going to actually calculate age.
yeah. Yeah.
Like, you know, we actually calculate age, so
Right. No, yeah, it's actually got to get to recalculate this whole expression. It's gonna say what's my age and then what's my fertility rate for age and use it for this rate. Okay, so ladies and gentlemen, we're just about done with this. What I'd like to do now is I'd like to report this happy event. Okay, I'd like to report a birth has occurred. To whom? So, ladies and gentlemen, we're going to add a little bit more to this. Where this add population occurs, we're going to have the baby. We're going to have a variable that keeps track of the baby, who the baby is. And we know who the mother is. It's this at this point. So what is the baby? The baby is a person. So we're going to say baby equals this. So add population actually returns, it gives back, ladies and gentlemen, a person. And that person here is none other than the baby, the infant, the neonate. There it is. This is a familiar health term for it.
I'm sure it is.
Yeah. Okay. 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 My students are joking about this neonate being developmentally challenged.
Talking about the little person, is, you know, they
Okay.
don't have all their development complete.
Okay.
Like,
Okay.
we can use neonate, we can call them
Anyway,
tiny humans.
moving right along. Yeah. So, ladies and gentlemen, I'm going to show you something really useful about AnyLogic. Okay, and that will be we're going to report actually in text some important information, and we can do this on a regular basis using a tool that's called trace-ln. This will print something out on the console. It'll print something out that indicates something has happened. And this is extremely useful when you want to figure out if a certain event is occurring or why it's occurring, when it's occurring, sort of thing. So we're going to say trace-ln. Okay? Now, we probably could say this.trace-ln if we want to be really specific about it, although I think that's the first time I've ever done that. Okay, I'm going to say a new baby, and I'm going to say plus to mean concatenate the string, append the string. I'm going to say baby that's going to be the name of the baby. That's going to turn that into a name. A new baby was born to mother plus this, and I'm going to say at time, and it's going to be the current time. Let me put this up on the big screen. Okay? I'm just going to report the joyous event. There it is. This is what it is. So this trace-ln is going to take some string. It's going to take some string, and it's going to print it out. That's how it works. The string that's going to be printing out is a concatenation of several things. It's going to say a new baby. It's going to give the name of the baby. Was born to mother. It's going to give the name of the mother at this certain time. At time, let's put a colon in there, and it's going to print out the time. It's going to have the time at the end of the string. All of this is going to be turned into a string, which is then going to be printed out. Okay? And you could shorten it if you want to make it new baby, well, you know, born to mother, if you want to cut out these was, born to mother, this, at time, if you want to shorten it. Okay? But in any case, the point is we're going to have a report printed out when a baby is born. Can we do it? And this is going to show us when the babies are born in the model. Okay? Okay. 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 So, okay, ladies and gentlemen, I'm going to run this model with that logic in there, and we're going to see over here in the model, look at that, porting it. See that? Do you see that? Look at that. Okay. Okay.
How many overriding baby?
Well, each time it's just transiently creating something. This code is just transiently running. All these names are forgotten after this runs. Those are just convenience names for this time.
Because you said person baby is name, right? So baby is the existence within person.
No, it's just a temporary name. So
Every time there's a new birth, it gets called baby.
That's right. That's right.
So we are overriding baby.
No, there's no consistent variable. That variable comes into existence only while this code is running, and then it disappears. It's only a convenience name in the context of this code, and then it disappears. It's unlike, say, sex or mother, which stick around. This baby does not stick around. This name for the baby does not stick around. It's just a convenience name while you're referring to this. While you're referring to this particular bit of code, and then there's no overriding going on. It's a separate, every time it runs, it creates a little variable and says, okay, who's the baby, and it doesn't change the old baby. Yeah. Okay. So ladies and gentlemen, did you see that printing out? Did you see it printing out? Okay, great. Okay, ladies and gentlemen, I'd like now to do one final thing. Let's set the baby to be near the mom. What do you think? You think? Okay, so we're going to say baby. We're going to say baby dot set xy, okay? So we're going to say baby dot set xy, and we're going to set it to be near the mom. And the way we're going to do this is we're going to say, now, the problem is I'm going to be referring to this. Who is this here? This is the mom. Let's give a better name for her than just this. I mean, after all, you could use it once, but let's give her a name. So I'm going to say person mother equals this, just to be clear. So I can use the name mother, and it'll be very clear to what I'm referring, okay? So the baby is born with the mother being a mother. And then I'm going to set the baby's x location to be the mother.getX plus some normally distributed perturbation. Okay? Now, those from statistics background need to steel themselves for an ugly fact. Okay? I'm terribly sorry. I was shocked to see this. I was shocked. And it's a really unsettling fact. You could call to draw a value from the normal distribution AnyLogic. Great. It draws a value from a normal distribution. Samples from the normal distribution. But when you call that, you have to specify a mu and a sigma, but they're specified in the reverse order than you'd expect. You have to specify the sigma first, and then the mu, which is wacko as far as I'm concerned. So the sigma here will be 10, and the mean will be 0.
That's got to go in
Oh, sorry. What am I doing? There we are.
You could also use the distribution editor, or the distribution wizard.
I could. I showed that yesterday, and I
You don't need to say 10
I probably should, just to inoculate you folks, just to lower the chance you'll accidentally put 1 over 10 and end up in a world of hurt. Just get in the habit of putting 0.0 when you're dealing with things that are floating point numbers. Sure, that's better. Thank you. Okay, I love it. You folks are policing me in a good way. Okay, there it is. Okay. So there it is. So what we're doing, we're setting the baby's X and Y location to be the X and Y location of the mother plus a normally distributed perturbation, a normally distributed nudge around there of standard deviation 10. So on average, they're centered over the mother, but they have some standard deviation offset. Are we okay with that? Let's go see what happens. Can we go see? Okay, watch this. You ready? Who needs help? All the TAs are sitting, but there's help needed.
We're helping me, actually.
Just discussing scoping and whatnot. Good ways to.
Yeah. Okay, who needs help? The TAs are deployed. They've emerged to engage in deployment. Okay, ladies and gentlemen, let's run it with no immigration. Let's go see what happens. What do you expect to see? Well, you get kind of clustering. Unfortunately, it's still, the death rate is still too high and the population dies out. But you get more clustering of the population. Okay. Maybe we'll go and increase this fertility rate a little bit. Ladies and gentlemen, for the fertility rate for age, I'm going to make the value at 25 go to 0.1 instead of 0.05. Is that okay?
It still died quite quickly, I do that.
It did?
Yeah.
Okay, 0.15. Let's try that. I should have. Oh, there we go. Yeah. 0.15. Make it 0.15 at 25 for the fertility rate, and you'll get a very different situation. Why are we seeing such clumping? The births occurred close to their mother, and so these are clans. Those are clans being formed of sort of related individuals, right? You have sort of groupings going on based on the births that have occurred. Now, for each one of these people, if you drill down, let's just pause it for a moment. You'll drill down to a particular person. Here, okay, this person's mother has died. That's why they're shown as being root population -1. Okay, this person's population. Let's go further into it. I'm going to go to person 800. This baby was born to mother 463. This baby is at position 800. The mother was at position 463, and it's apparently still alive. This one's born to 461. This one's to 399. This one's mother has passed away, hence it's -1 for the mother. So we actually get some rather different patterns coming out of that, patterns that are reflective of social groupings, family groupings, really. Okay.
Now, Nate.
Yes.
The reason that the population is otherwise dying out, that maybe it was just a product of the age distribution? Because I know some people in the class might have different, people of childbearing age of their population versus others. So I'm just trying to find an explanation as to why some people will have good populations and others don't.
Had populations go extinct? Well, remember, the initial age pyramid for the population is a fairly transient thing. They age over time. And so it's unlikely that distortions in that would lead to long-term imbalances with the population dying out. It's probably something else involving the mortality and fertility relative to each other.
I think 1.5 more. If you put it 1, then I would 1.
Could you show us the baby color? So
One is not working.
The baby,
the color.
the color? You want to have a different color for the baby? Okay. How would I do a different color for a baby compared to an immigrant or compared to someone who was born in the model? Suppose we wanted to have them have different colors depending on their history. So we want native born versus those who were immigrants versus those who were in the model from the start. How are we going to do that? What could we give them that would tag them? We could give them a color. So let's create a parameter that's a color. Let's go give them a color. And so this will be called their, now this could be done in a different way, and I have some misgivings about doing this, but this will be called their origin color. I have misgivings about doing this, but I'm going to.
Can I have a question?
Sure.
Yesterday you do color as variable.
Yes.
Now
Yeah.
you do it as a parameter.
You got it.
Why?
Because they serve a different function. Origin color will be set once at when this person is created, and it will forever after be the same. Remember, parameters are used for more or less static quantities that are specified at the time of creation, and then they tend not to change, and they indicate the assumptions about this person. A variable that we set yesterday had a very different purpose. Origin colors can be set once when they're created and persist. It's a very nice match to a parameter. Yesterday, we had a variable color, and that changed as they were going between states of a state chart. So that wasn't appropriate for a parameter. That was a variable type of thing. So it's the function of it. How does it, the role it serves in the model.
But does a baby become a mother?
A baby becomes a mother in the fullness of time if it is a she. And this origin is simply denoting whether they were born in the model, whether they were in the model from the very get-go, from the initial time, or whether they're an immigrant. That's the function of this. Okay, are we ready to see the color?
Yep.
Okay, ladies and gentlemen, I added a parameter called origin color, for lack of a better term. I would welcome a better name. So what type will this variable be, or this parameter? It will be other. That's exactly right. And what will the other be? Color. Yeah, it'll be color. Okay? Great. Okay, and its default value will be black, right? Okay, so color is spelled using the American spelling, but we could call it origin color using the Queen's English. Okay, so it's initially going to be black, but we don't expect the default value to be used much. Now, every place, so having added that, if we build the model, do you think it will be happy? No. What will it complain? You got to go add it in as a parameter to every time you created that person. So let's go. Here's our problems window. The problem is your friend. The problems window is your friend. It will alert you to problems before you run the model. You don't want problems while you're running it. You'd rather they be found before you run it. It's kind of like if there's a problem with your car, you want to find it, with your brakes in your car. You want to find it before you start driving, rather than while you're driving.
This is a pretty good analogy.
Right? Okay. Well, it's actually even worse than that, because a lot of the time, if there's something wrong with your model, you might not even know it. And it's not like your brakes where you know it pretty soon, but it's even worse. You won't even know. Okay, so add population, that's first one. Every time we create a person, we're going to need to specify their color. Okay, so for someone who's an immigrant, what color? I don't know. Make them green. Okay, we'll make it green. Good, green. Okay, someone who is, this next one will be a baby. What color to make that? Baby blue? Blue.
Orange will stand out.
Orange? Okay, does anyone have a strong opinion?
Yellow, that's what you paint babies when you don't want
Yellow?
Lime green.
Lime green.
Yeah, you're lime green.
You want lime?
Yeah, 'cause
I
you
think
get lime.
Nate,
It's like-
type the word medium and then press Control Space. And you have a whole. You could do medium orchid if you wanted.
Oh,
Wow, awesome.
What is orchid color?
Purple.
It's a purple kind of a purple. It's a pretty nice color actually. Why don't you use it and see what it looks like?
Okay.
I'm going medium orchard.
Okay, medium orchid. Okay, that's great. And then there's one other place we need to specify their color. Where is it? It's no, it's in the population. Remember, the population has to specify these things too. Now, the population is specified. Who are these people specified in the population? Those are the initial people. That's what that population characteristics. This is for the initial population. This is an important point of having an open model. These folks, these are the characteristics of the initial people in the population. After that, people are being added in dynamically. It's saying add population when a baby is born, when an immigrant comes in, they're added to the population. Okay, so this is just for the characteristics of the initial population. We're going to have people who are in the population initially. We don't know who their mother is, so we'll just set it to be null. And their initial color will be what? What color do you wish for them? Notice we can pick or we can specify in code. What would you like it to be?
I just think it should be black.
Okay.
That's your default color, and so if you see black people, you know you've got a problem.
Okay, do you want to make it red? Good point. Excellent point, Joe. You're thinking, I don't know if this is a good thing, but you're thinking like, I don't know if you'll consider it a good thing. I consider it a compliment. You're thinking like a programmer. You got to be thinking offensively. How can I design this so that if my model has a problem, it will show up? And so you set the default color to be black, which is an unused color. You'll never use it if the model's working. And if you see black, you know there's something broken. That's a key insight. Okay, ladies and gentlemen, should we set it to red? Red? Okay, now let's...
When we ran it before, we didn't have mother null, right? Even though we had mother in it.
Yeah, it secretly substitutes null there. I'm sorry to say. Okay, so let's run this thing, and let's see. Okay, oh wait, there's a whole bunch of black. Okay, that doesn't make. Oh, of course. What haven't we done? We haven't linked it up to the person's picture. Okay, this thing says, for person, it says origin color, but where is that enforced? Like, where is that operationalized? Where is that actually actualized?
You have to click on that shape of the person.
You have to click on the shape of the person. Now, this is a tedious process. You can click and you can frob, and you'll eventually get. But I'd prefer to show you a better way. If you go to person and you go to presentation, and to person you go to shape body, and that's where you can set the fill color. Do you see that? Do you remember that? Over here in this model view, you expand presentation, expand person, expand shape body, and you pull down for fill color. You pull it down and you will put in origin, this dot origin color. There we go. Are you ready? Sorry? Do you want to say self?
I don't know.
No, you don't want to say self. Self is used when you want to refer from one parameter to another while they're being created in the initial population. It's also used in discrete event modeling. Self is not used in a broad set of contexts. It's really this. Self is used very rarely, comparatively rarely.
Haven't you also defined the parameter origin color black?
We did define it to be default black, but my hypothesis is it's just because this was not set up to use it. So if we run it now, we should see, if my hypothesis was correct, we should now see it have no black color. There we are. That's the initial population. Who are these coming in? Are those babies? Oh, in the no immigration case. Okay, those are babies coming in. Okay, those are all people who got born here. Those are the currency. Okay? Okay, so let's run this here, and now the immigration, and now the green are the immigrants, the ones in this so-called medium orchid are the people who are born into the model, and there's a few of the original population, the old stock remaining left. Okay. Yes, Tom.
Yeah, I just got to.
Oh.
Okay. I'm going to ask him something.
Yeah, no.
Script a little bit. I have an interesting little visualization thing to show them. You might get some using homes.
Okay.
So as women get closer to their max fertility age, let's say max fertility rate, let's say it's 0.1.
Yeah.
Whatever it was. We use light color in the body rather than a solid color. So people who are not of childbearing age or aren't going to be fertile are white. The closer they get to it, the brighter the color happens to be. So people are born, and you can start to see when they get into their 40s or into their 30s because they start running out. So something to mull over, but I just think it might be, this is something I end up using a lot, and that makes me
Yeah, no, I was thinking about rolling it into another one.
Okay. I'll leave that there, and we'll...
Yeah.
Anyway, another time. Just thought of it.
Okay, appreciate it. Why are we having people link, sort of coming out the sides? Yeah, you put a normal distribution around mums, and so the babies get born outside the square. Okay, ladies and gentlemen, I think we'll stop there because I need to allow Kurt. Where's Kurt?
Right here.
Oh, okay.
Because it's
Okay.
whatever so probably what's happening is
Oh, I only changed the.
Okay, are there any questions about this model? We have an open population model. Yes, Alex.
the migrants give birth.
Yeah, the migrants do give birth here. So we make currently no distinction. It's a great question. We make no distinction in the coloration here as to whether it's a child of a migrant or a child of someone who started life in Australia.
That's what it looks like the original population flying out.
Yeah, exactly. Yeah, and so, but migrants do give birth here, and so they'll boost the population.
Godlike. So Joseph is godlike.
I'd like a copy of that. Okay, thanks, Jeff. Okay, ladies and gentlemen, I'm just seeing a somewhat disconcerting photo of myself. Okay, so any questions further about this model before we move on? This is a model of an open population. We saw how to incorporate age-specific mortality, fertility, and we saw how we could capture immigration rates. We also saw how we could make the structure of the population of the initial population drawn from an age distribution, or the age structure of the immigration process also be drawn from an age distribution. So it has packed a lot of information in it. We also saw how we could keep track of events that linked up different generations. We could keep track of someone's family structure, including their mother, which would allow us to track family dynamics if we wish to. We also saw how we could use this thing called trace-ln to nicely report the occurrence of certain events of interest. So this trace-ln can alert us when certain things happen in our model, which could let us, for example, report if an event is occurring. We could do a trace-ln there. It doesn't have to be fancy. You could just say trace-ln quote, $1 to indicate when a certain event is firing. And if you don't see that being printed, you can have confidence that event is never being reached. So it's a really good way to test whether the model is reaching certain places, how often it's reaching it. trace-ln is one of the foremost tools in our toolbox of diagnosing what's going on in the models. Okay? So that's just a little bit of of how this, of some of the features of this model. We also saw a little bit more about state charts, and we learned that in order to track and to keep track of these transitions out, we can get it to recalculate rates out of a given state using this departure here, okay? It's unfortunate that AnyLogic doesn't automatically recalculate rates and timings, but this is one way you can make it work when you have things that are changing. You do not need these recalculate transitions if this output is depending on characteristics that are set by other state charts changing. For example, if it depends on a formula that depends on what state you're in another state chart. When you change that other state chart, and the states in the other state chart, it will change this rate. Okay? So just a little bit about that model. I know it was an awful lot. Any questions that I can answer about it? Okay. No questions? Okay. So I think it's about 12. Jeff, what time is lunch today? 12:30. Okay. Okay. Just trying to think how best to use the next half hour. Kurt could start. Just trying to think here. Okay, we're going to use this time to do a few more things with statistics because, Kurt, you're going to need a longer period of time. You're not going to be able to do it in half an hour.
Sure, that's true.
Okay?
Yeah.
Okay, ladies and gentlemen, we are going to print out, we're going to add something we've never added before to this model. We're going to add a chart that's going to track over time the number of people in the population. Are we ready for this? Okay, so I'm going to stop this recording. This will be